The year is 2250, the world has changed in ways our ancestors could barely imagine, yet the sun still rises, casting its golden light over a city that feels both familiar and entirely new. On the 13th of January, Alara stands on her balcony, watching the sun rise over Neo-Alexandria. The city stretches before her, alive with promise and the quiet energy of a new day. The city breathes, solar sail towers pivot like silver flowers, capturing the dawn. Their petals shimmer as they track the sun, powering homes, schools, and dreams. Maglev pods glide silently through green corridors below, weaving the city together with ribbons of light and motion. There's no roar of engines, only the hum of a civilization in harmony with nature. The air vibrates with a gentle energy, a far cry from the chaos of centuries past. Alara sips a nutrient drink, algae grown in vertical farms that climb the towers. These living skyscrapers are more than architecture. They're ecosystems, feeding the city and cleaning its air. Her AI, Orion, offers a schedule for the day, its voice gentle and familiar, woven seamlessly into her morning routine. Quantum botany, a field that merges science and wonder, where plants are engineered to thrive in any environment. A virtual Europa outpost tour, connecting her to explorers on distant moons, reminding her that humanity's reach now extends far beyond Earth. A community art gathering where creativity and collaboration are celebrated as the heart of progress. Her life is about learning, creating, and connecting, not survival. Each day is an opportunity to grow, to share, and to shape the world alongside others. This is humanity's leap, working with each other and the planet, not against. The city is a living testament to what's possible when cooperation becomes our foundation. The air is clean, filtered by plants woven into the city's structure. Every breath is a reminder of the balance struck between progress and preservation. Parks flow like rivers of biodiversity, connecting every district. These green arteries pulse with life, inviting people to wander, reflect, and reconnect with nature. Birds sing from resilient trees, canals teem with fish. Wildlife thrives alongside humanity, a daily reminder of the city's living promise. This ecosystem is the masterpiece of the Great Rebalancing, a global promise kept. It's a living legacy, shaped by generations who chose hope over fear. The archives show a world once divided, polluted, and fearful. Images of smog-choked skies and fractured societies are now lessons, not warnings. That fear sparked a revolution of ideas, not weapons. Innovation became the new defense, and imagination the new frontier. We saw our planet as a single, interconnected spaceship. Borders faded, replaced by a sense of shared destiny and responsibility. We realized we were all crew on the same journey. That idea changed everything, inspiring a new era of global teamwork and trust. Alara looks out at the peaceful dawn, a living testament to centuries of effort. She feels the weight of history and the lightness of hope in equal measure. The city's design is intentional, nature and technology intertwined. Every building, every street, every garden is a choice to honor both progress and the planet. Every sunrise is a reminder of what's possible when vision becomes action. The city glows with the promise of new beginnings. The past's turbulence is now history, studied and learned from. Its lessons are woven into the city's very foundation. The city's harmony is not an accident but a choice. Every detail reflects the collective will to create a better world. The Great Rebalancing was humanity's turning point. It was the moment we decided to heal, to innovate, and to unite. Now, the future is not feared, but embraced. Each day is a step forward, a chance to build on the dreams of those who came before. Neo-Alexandria stands as proof. We can build a world worth inheriting. It is a beacon, shining for all who dare to imagine a better tomorrow. This is the beginning of our journey to 2250, a journey shaped by hope, guided by wisdom, and fueled by the endless possibilities of a new dawn. Daily life in 2250 is a seamless blend of technology and humanity, where innovation is woven into the fabric of every moment. The city hums with quiet intelligence, and homes are sanctuaries of comfort and connection. Alara's biofabric clothes adapt to her needs, shifting color and texture for comfort or style, and when worn out, they gently dissolve, returning nutrients to the earth. Fashion is no longer wasteful, but part of a regenerative cycle. Every object in her home is designed for sustainability and function, From self-cleaning surfaces to furniture grown from living materials, the air is always fresh, filtered by living walls and smart ventilation. Work is project-based and passion-driven. Alara, a quantum botanist, collaborates globally in immersive virtual spaces, sharing discoveries instantly with colleagues from every continent. Distance is no barrier to creativity or teamwork. Food is fresh, local and lab-grown. Famine and malnutrition are history. Vertical gardens and cultured proteins ensure everyone has access to nutritious meals, grown with minimal impact on the planet. Healthy food is a universal right, as basic as clean air and water. Children learn to appreciate flavors from around the world, and communities gather to share meals in celebration of abundance. Personal AIs like Orion are lifelong learning companions, adapting to each person's needs, helping with daily tasks, and nurturing curiosity from childhood through old age. Augmented reality provides seamless information, overlaying guidance and inspiration onto the world. But digital mindfulness is valued. People know when to disconnect and simply be present. Scheduled disconnection is common. People walk, talk, and connect face-to-face, cherishing moments of genuine human interaction in parks and public spaces. Technology is a tool. The human experience is the purpose. It enhances life, but never overshadows the importance of empathy, creativity, and connection. This is the symphony of a balanced, mindful society, where progress and compassion move in harmony, and every day is a celebration of what it means to be human. The Great Rebalancing began with a global shift in consciousness. Fusion power and renewables ended the fossil fuel era. Carbon scrubber ships and reforestation reversed environmental damage. Bioengineered nanobots cleared microplastics. Lab-grown corals revived reefs. The Earth's recovery became a cultural mission, not just a scientific one. Generational responsibility is now a core value. Each generation must leave the planet better than they found it. Children learn their role as guardians of Earth from the start. Restoration is ongoing, but our relationship with nature is transformed. We are stewards, not exploiters. The planet's healing is humanity's greatest achievement. Social transformation blossomed alongside the environmental revolution, reshaping the very fabric of our daily lives. The Universal Basic Opportunity System now guarantees every person access to safe housing, nutritious food, quality healthcare, and lifelong education. No one is left behind. With the burden of survival lifted, people are free to explore their passions, innovate, and contribute to society in ways once unimaginable. Automation and AI, once feared as threats, now fund the public good, powering communities, and supporting shared prosperity instead of private profit. Dynamic democracy empowers citizens to shape their future, voting on policies through secure digital platforms, with guidance from transparent, unbiased AI analysis. Civic engagement flourishes, and trust in institutions is renewed as people see their voices reflected in real decisions. The old boundaries of nation and race have faded. Now, cultural diversity is honored and celebrated within a vibrant shared Earthling identity. Governance is collaborative, not divisive, as communities and nations work together for the common good. Our unity was forged in times of crisis and strengthened by our bold steps into the cosmos. From the moon, we see no borders, only one fragile, beautiful blue world suspended in the vastness of space. This new perspective changed us forever, awakening a sense of shared destiny and responsibility. We are one human family, living together on a single precious planet that we must protect for generations to come. That unity, hard-won and deeply cherished, is now our greatest strength, guiding us toward a brighter future. Education is lifelong and personalized, guided by adaptive AI mentors. Learning is curiosity-driven, virtual dives, hands-on projects, and global knowledge networks. Anyone can learn anything, at any age. Social networks foster real relationships and community projects. Cities are designed for connection. Public squares, gardens, workshops. Mental health is prioritized. AI wellness companions support mindfulness and well-being. Economic security and purpose have reduced mental health crises. Empathy and compassion are core values. A healthy society cares for minds and bodies alike. Connection, digital and physical, is the foundation of our world. Exploration thrives on Earth as much as in space. Deep-sea habitats powered by geothermal vents reveal new life and medical breakthroughs. The ocean's mysteries inspire awe and innovation. Antarctica's research cities are self-sufficient, zero-impact marvels. Scientists study climate history and geology with advanced, non-invasive tools. The continent is governed as a continent for science, a model for future worlds. Living in extreme environments deepens our respect for nature. The lessons of the Great Rebalancing guide us everywhere. Understanding and harmony with nature are essential for survival. Earth's wonders still shape our destiny. Unity on Earth reignited our cosmic ambitions. The Moon City, Armstrong, is a hub for science and industry, listening to the cosmos. Mars hosts Sagan's Hope, a thriving, self-sustaining settlement. Terraforming is slow, but pioneers plant the seeds of a multiplanetary humanity. The first Martian child, Curie, symbolizes a new future. Robotic explorers probe Europa's ocean, finding organic molecules. Space exploration is a shared quest, not a race. Innovations for Mars benefit Earth. The search for life deepens our appreciation for our own planet. The cosmos gives us perspective and purpose. Our journey outward is a journey home. The Global Endeavor Framework empowers mass collaboration on planetary projects. Anyone can propose an endeavor, science, art, or technology. AI and peer review allocate resources to promising ideas. Boundaries between amateur and professional have blurred. Creativity and passion drive progress. The living library of Earth sequences every species' genome, safeguarding biodiversity. Millions contribute as citizen scientists. Global artistic projects like the Global Symphony unite cultures in shared creation. Endeavors build a common purpose and global culture. Progress is collective, not individual. This is how we build the future, together. In 2250, we look back with understanding, not condemnation. Our leap forward was one of wisdom, empathy, and unity. We are part of nature, not separate from it. Our differences are strengths. Our destiny is exploration, not conquest. The future is a vast ocean of possibility. New worlds, new art, new questions. Challenges remain, but we face them with confidence and shared purpose. Our story is written in the stars. We are stardust, the universe knowing itself. The cosmos is within us. Look up. On a clear night, far from city lights, the sky reveals its true majesty. A velvet blackness, sprinkled with countless stars. Each point of light is a sun, many with their own planets. We are part of a vast, interconnected cosmic web. For millennia, we've gazed upward and asked, what is out there? How did it all begin? Where are we going? The universe invites us to wonder and explore. The light from the nearest star takes years to reach us. From distant galaxies, millions of years. Every glance at the night sky is a look back in time. This vastness is filled with wonders, swirling nebulae, ancient clusters, galaxies colliding. Yet, within this tapestry, some regions defy understanding. These are the places where physics breaks down, calling to the explorer in all of us. The greatest mysteries lie in places we can never visit, places of extreme gravity and unimaginable density. The ultimate frontier isn't a place, but a boundary. The event horizon of a black hole. Here, space and time are warped beyond recognition. Black holes are the universe's most extreme objects, the final punctuation marks at the end of a massive star's life. To understand the universe, we must dare to approach this edge and trace the faint signals that escape from its precipice. What is an event horizon? Imagine throwing a ball into the air. Gravity pulls it back unless you throw it fast enough to escape Earth's pull. For Earth, that escape velocity is about 11 kilometers per second. Now, picture an object so massive that its escape velocity exceeds the speed of light. That's a black hole. Nothing, not even light, can escape once it crosses a certain boundary. This invisible boundary is the event horizon. Think of it as a cosmic waterfall. Far from the edge you can turn back, but cross a certain point, and there's no return. The event horizon isn't a physical surface, but a boundary in space-time. If you fell through, you wouldn't notice the moment, but your fate would be sealed. No information escapes from within. What lies beyond is hidden from our universe. The event horizon is a cosmic veil, concealing the singularity at the black hole's core. Everything that falls in, matter, light, history, is lost to us. This is what makes black holes so mysterious. They are the ultimate boundary of our knowledge. Here, our theories are pushed to their absolute limits. Black holes are forged in the universe's most violent events. Their story begins with massive stars, 20 to 30 times the mass of our sun. These giants burn bright, fusing elements in their cores and balancing gravity with energy. But fuel runs out. The star fuses heavier elements until it reaches iron, which consumes energy instead of releasing it. The core collapses in a heartbeat, triggering a supernova, an explosion that outshines entire galaxies. The outer layers blast into space, seeding the cosmos with heavy elements. But the core's fate is more dramatic. If massive enough, gravity wins, crushing the core beyond all known states of matter. It collapses into a singularity, an infinitely dense point. Around it, gravity warps space-time so severely that nothing can escape. A black hole is born, its event horizon marking the tombstone of a once mighty star. These cosmic remnants are invisible, but their influence is immense. They shape galaxies, power jets, and challenge our understanding of physics. Black holes are not just the end, they are a new beginning for cosmic exploration. Their birth is both an ending and a gateway to the universe's deepest mysteries. And it all starts with the death of a star. If nothing escapes a black hole, how do we find them? We look for their effects on nearby matter. Black holes are messy eaters. Gas and stars spiral into a superheated accretion disk. This disk blazes with X-rays as matter accelerates and heats up. Space telescopes like Chandra detect these X-rays, revealing black holes by their invisible pull. In binary systems, we see stars orbiting an unseen companion. Calculating its mass reveals a black hole, but to glimpse the event horizon itself, we look for the shadow it casts on the glowing disk. The event horizon blocks light, creating a dark circle, a silhouette predicted by Einstein's theory. Capturing this shadow is the ultimate confirmation of our understanding. It's the closest we come to seeing the edge of spacetime. The hunt for these signals pushes our technology and imagination to the limit. Seeing a black hole's shadow is a monumental challenge. The supermassive black hole at our galaxy's center is 26,000 light-years away, like spotting a grapefruit on the moon. No single telescope is big enough, so scientists created the Event Horizon Telescope, EHT, a global network of radio telescopes. These telescopes, synchronized by atomic clocks, observe the same target simultaneously. This technique, called Very Long Baseline Interferometry, creates a virtual telescope the size of Earth. The EHT achieves unprecedented resolution, powerful enough to see the unseeable. Each telescope records massive amounts of data onto hard drives. These drives are flown to central processing centers. Supercomputers combine the data, correcting for the atmosphere and assembling the final image. It's like piecing together a cosmic jigsaw puzzle. The result, a lens sharp enough to reveal the edge of a black hole. The EHT targeted two black holes, Sagittarius A in our galaxy, and the giant at the heart of M87. M87's black hole is a monster, 6.5 billion times the mass of our sun, 55 million light-years away. In April 2017, the EHT network observed M87 for days, collecting petabytes of data. After years of processing, the world saw the result in April 2019. For the first time, we had a direct image of a black hole's shadow. The image showed a bright ring, the accretion disk, surrounding a dark center, the event horizon's shadow. It matched Einstein's predictions perfectly, confirming our understanding of gravity. This was a triumph of human collaboration and ingenuity. Hundreds of scientists, dozens of countries, one audacious goal. We were no longer just inferring black holes, we were seeing their silhouette. The journey to trace the signal from the event horizon led to a historic picture. It turned theory into reality. A new era in astronomy had begun. Capturing M87's image was a monumental feat, but the challenges are immense. The required resolution is extreme. Any tiny error can ruin the observation. Atomic clocks must be synchronized to a trillionth of a second. Earth's atmosphere distorts radio waves, so telescopes are placed at high, dry sites. Scientists use complex algorithms to correct for atmospheric distortion. Black holes are difficult targets. Their accretion disks change rapidly, smearing images. M87 Non was easier because its disk changes slowly. Our galaxy's black hole is more chaotic. The EHT generates more data in a night than the Large Hadron Collider does in a year. Every step, from data collection to image reconstruction, pushes technology to its limits. Why go to such lengths for a shadow? It's about testing the foundations of our understanding. Einstein's theory of general relativity has passed every test. Until now, we couldn't test it at a black hole's edge. The M87N image matched predictions, confirming our theory under extreme conditions. But this is just the start. By studying these images, we search for tiny deviations, potential cracks in Einstein's theory. A new theory could unite relativity and quantum mechanics, revealing a deeper understanding of reality. These signals also teach us about black holes' spin, how they consume matter, and how they shape galaxies. Supermassive black holes are engines that influence the cosmos. Tracing their signals helps us understand the universe and our place within it. Tracing the signal from the event horizon is more than science. It's a story about us. It's a testament to human curiosity and collaboration. No single person or nation could have captured that image. It took a global effort. This journey reminds us of our place in the cosmos, small, but with boundless curiosity. We build tools that extend our senses across space and time. We dare to glimpse the edge of a black hole, 55 million light-years away. The quest continues. The EHT is expanding. Future images will be sharper, and we may even create movies of black holes in action. We'll probe magnetic fields, search for cracks in Einstein's theory, and unlock new physics. The abyss is giving up its secrets, one photon at a time. We are explorers, driven to chart the unknown. The event horizon is the edge of our understanding. By tracing its signals, we learn about black holes, the universe, and ourselves. The journey beyond the stars continues, toward a deeper understanding of who we are and the universe we call home. The universe is a vast cosmic ocean, scattered with galaxies, each a cradle and grave for stars. Some stars, the true giants, end their lives in a spectacular collapse, forming black holes. A black hole is a region where gravity is so intense that nothing, not even light, can escape. These are not empty voids, but cosmic enigmas that challenge our understanding of reality. Imagine journeying to the edge of a black hole, a place where the laws of physics are pushed to their limits. We'll stand at the event horizon, the boundary between our universe and the unknown. This is a journey of imagination, powered by science. Through thought experiments, we can explore what it would be like to fall into the deepest gravity well in the cosmos. Our destination, a place of ultimate darkness, where space and time are twisted beyond recognition. As we approach, clocks slow and starlight bends, Einstein's general relativity in action. Gravity here is not a force but a warping of space-time itself. Nowhere is this warping more extreme than near a black hole. Prepare yourself, we're about to explore one of the universe's greatest mysteries. Black holes are cosmic laboratories, letting us test the very foundations of physics. By studying them, we learn about the life and death of stars, the structure of galaxies, and the nature of gravity. They may hold the keys to the deepest secrets of the cosmos. So, let's begin our journey. Step aboard our ship of imagination. Set a course for the abyss. The universe is waiting to reveal its secrets. What exactly is a black hole? Let's break it down. Gravity keeps us anchored to Earth, but to escape it, a rocket must reach a certain speed, Earth's escape velocity. Now, imagine an object so dense that its escape velocity exceeds the speed of light. Nothing can escape, not even light itself. That's a black hole. Black holes are born from the death of massive stars. When a giant star runs out of fuel, gravity wins, and the core collapses into a singularity, an infinitely dense point. The space around this point becomes a black hole, but black holes aren't cosmic vacuum cleaners. Their gravity follows the same rules as any massive object. If our sun were replaced by a black hole of equal mass, Earth would keep orbiting as usual, just in darkness. You have to get very close to be trapped. Black holes come in different sizes. Stellar mass black holes are a few miles across, but can contain several times the mass of our sun. Supermassive black holes, millions or billions of times more massive than the sun, lurk at the centers of galaxies. Our own Milky Way harbors one, Sagittarius A, with a mass of about 4 million suns. These giants shape their galaxies, influencing star formation and galactic evolution. Black holes are crucial to the cosmic ecosystem. They're not just destructive, they're fundamental to how the universe works. Their study helps us test and expand our understanding of physics. They're the ultimate proving ground for our theories, and they remain some of the most fascinating objects in the cosmos. Let's get closer. Every black hole is surrounded by an invisible boundary, the event horizon. It's not a surface, but a point of no return. Imagine a waterfall. Far upstream, you can escape, but cross the edge, and you're swept over. The event horizon is that edge, but for light. Once crossed, nothing escapes. Not even information. The size of the event horizon depends on the black hole's mass. From a distance, it appears as a perfect sphere of darkness. If matter is falling in, it forms a glowing accretion disk around the event horizon, a brilliant ring with a black center. This is the black hole's shadow, a stark reminder of its power. Surprisingly, crossing the event horizon of a supermassive black hole would feel uneventful. No sudden jolt, just a silent transition. The real drama lies ahead, but at this threshold, you've left the universe as we know it. You're now on a one-way journey into darkness. The event horizon marks the boundary between the known and the unknowable. Beyond it, the rules of reality begin to unravel. Your journey into the abyss has truly begun. Our imaginary voyage begins at a safe distance from a supermassive black hole. It appears as a black marble against the Milky Way's stars. We fire our engines, not to speed up, but to let gravity pull us in. As we drift closer, the event horizon grows, eclipsing the stars. Starlight bends and warps, a phenomenon called gravitational lensing. The black hole's gravity acts like a cosmic lens, distorting the universe around it. We see stars in strange places, the universe becoming a hall of mirrors. Gravity's pull intensifies. Our ship accelerates toward the event horizon. Looking back, our signals stretch and slow, gravitational redshift in action. The accretion disk, if present, blazes brighter than 1,000 suns, swirling around the perfect blackness at the center. We're on final approach. The point of no return looms ahead. The pull is relentless. There's no turning back. We're committed to the fall, ready to face the unknown. The edge of the known universe is just moments away. Near the black hole, gravity distorts not just space, but time itself. The stronger the gravity, the slower time passes. For us, time feels normal, but to a distant observer, we slow down dramatically as we approach the event horizon. Our signals stretch, our image fades, and we seem to freeze at the edge. Light from the universe behind us is compressed into a shrinking, blinding window, blue-shifted and intense. Looking forward, there's only darkness. Looking back, we see the universe's future racing by. To outsiders, we never cross the event horizon. We're a frozen image on the brink. But for us, the journey continues. Time moves forward as usual. We're about to cross the ultimate boundary. The universe outside will speed up to its end, while we plunge into a realm where time and space swap roles. This is the heart of black hole physics, a place where reality itself is warped. We're ready to step into eternity. The point of no return is here. We reach the event horizon. No wall, no jolt, just a silent crossing. One moment, we're in the universe. The next, we're not. Inside, spacetime is fundamentally altered. Outside, we could move in any direction in space, but only forward in time. Inside, space and time swap roles. We're forced toward the singularity, as inevitable as the passage of time. The singularity is now our future. Every path leads there. No light or message can escape. We're cut off from the universe. For a while, we can still see the shrinking window of the cosmos behind us. This is the ultimate one-way journey. The laws of physics dictate our fate. All matter and energy are drawn to the center. There's no escape, no turning back. The journey from event horizon to singularity is swift, hours or days at most. We're now in the realm of the unknown, falling through a distorted reality. The heart of the cosmic monster awaits. We're deeper than anyone has ever gone. The singularity draws near. As we fall deeper, the black hole's tidal forces become overwhelming. Gravity is much stronger at our feet than at our head. This difference stretches us out. Our ship and our bodies are pulled into long, thin strands, a process called spaghettification. The closer we get, the more intense the stretching and squeezing. Eventually, even atoms are torn apart, forming a stream of particles spiraling toward the singularity. For smaller black holes, this would happen before reaching the event horizon. That's why we chose a supermassive black hole. Here, we survive longer before being torn apart, but the end is always the same. All matter is stretched and squeezed, destined for the center. Spaghettification is the ultimate fate for anything that falls in. It's a dramatic, inescapable end. The singularity awaits. What happens at the heart of a black hole? The singularity. According to current theories, it's a point of zero volume and infinite density. Here, the laws of physics break down. General relativity and quantum mechanics clash. We need a new theory, quantum gravity, to truly understand this realm. Some ideas like string theory or loop quantum gravity suggest the singularity might not be a point, but something stranger. Could black holes be gateways to other universes? Wormholes are possible in theory, but likely unstable. For now, the singularity remains one of science's greatest mysteries. It's a place where our understanding ends. The true nature of the singularity is still unknown. The quest for answers continues. Why do black holes matter? They're not just cosmic dead ends, they're vital to our understanding of the universe. Black holes test the limits of our theories and shape the evolution of galaxies. Their accretion disks can outshine entire galaxies, powering quasars and regulating star formation. Studying black holes pushes us toward a new revolution in physics, a theory that unifies the large and the small. Black holes may hold clues to the Big Bang, the fate of the universe, and the nature of reality itself. Mysteries remain. Do wormholes exist? What is dark matter? What happens to information that falls in? Stephen Hawking showed black holes can evaporate, linking gravity, quantum mechanics, and thermodynamics. The journey into a black hole is a one-way trip, but our quest to understand them will illuminate the universe for generations. Welcome, fellow cosmic travelers. Today we stand on the threshold of wonders our ancestors could scarcely imagine, embarking on journeys that redefine what it means to explore. Today is the 13th of January, 2250. The world as we know it has transformed, and so has our place in the universe. We live in a new golden age of discovery, an era our ancestors could only dream of. Our cities gleam with technology, and our ambitions stretch far beyond the horizon of Earth. For centuries, humanity gazed at the stars, wondering what lay beyond. The night sky was a canvas for our hopes, our myths, and our questions. Now we don't just observe, we visit. The mysteries that once seemed unreachable are now within our grasp. Our starships have become the caravels of the cosmos, charting new routes through the interstellar sea, carrying explorers to places once thought impossible. Crews of scientists and explorers venture beyond our solar system, driven to touch the unknown. Each mission is a leap of faith, a testament to human courage and curiosity. This is the story of one such journey, a mission to the edge of a supermassive black hole, Cygnus X1. Here, the laws of physics bend, and reality itself is put to the test. Our goal: approach its event horizon, the fabled point of no return, and witness phenomena that challenge our understanding of time and space. We seek answers to questions that have haunted humanity for generations. The risks are immense, but the potential for discovery is greater still. Every moment is a test of resolve, ingenuity, and teamwork. The Odyssey's crew carries the hopes of humanity as they push the boundaries of what's possible. Their journey is a beacon for all who dare to dream. They are not just explorers, they are pioneers, writing a new chapter in the epic story of our species. Their discoveries will echo through history, inspiring generations yet to come. Join us as we journey to the edge of reality itself, where the unknown awaits and the next great adventure begins. What is an event horizon? It's a question that has fascinated scientists and dreamers alike for generations. Imagine spacetime as a river, flowing gently far from danger. The current is calm, and everything moves along with ease, undisturbed by any cosmic threat. But as you approach a black hole, the current grows stronger and more turbulent, pulling everything relentlessly toward the edge, where the rules of nature begin to break down. The event horizon is the point where space-time itself flows inward faster than light could ever hope to travel. It's the ultimate boundary, where escape becomes impossible. Cross it, and escape is impossible, even for light. No signal, no matter how fast, can ever return from beyond this invisible line. This is the universe's ultimate one-way boundary, a point of no return that marks the edge of the unknown. Our mission, get as close as possible, without crossing, to study the extreme physics at play. Here, gravity is so intense that time itself slows down, and matter is stretched and twisted in unimaginable ways. The event horizon isn't a wall, it's a location in spacetime, invisible but absolute. There's no physical barrier, just a boundary defined by the laws of physics. For an astronaut, there's no signpost, just a silent, irreversible threshold. One step too far and you vanish from the universe's view forever. We aim to hover at the edge, to observe and measure what happens where the laws of physics are pushed to their limits, hoping to unlock secrets about gravity, time, and the very fabric of reality. It's a delicate, dangerous task, but the mysteries waiting there are worth the risk. Every reading, every observation could change our understanding of the cosmos. The event horizon remains one of the most enigmatic frontiers in the universe, a place where our knowledge meets its greatest challenge. We're not just chasing knowledge, we're confronting the very limits of reality, daring to explore where few have even imagined. This is why we go, to stand at the edge of the unknown, and to seek answers to the universe's deepest mysteries. To reach the edge of a black hole, we need a ship like the Odyssey, a marvel of 23rd century engineering. Over a kilometer long, its crystalline alloy hull shields 200 crew from radiation and gravity's extremes. Inside, hydroponic bays and Earth-like quarters sustain a life for years. Observation domes offer breathtaking views, while advanced sensors, graviton detectors, neutrino scanners, quantum communicators let us see and measure the universe in new ways. But the real breakthrough is the propulsion, a drive that bends space-time itself, letting us cross light years in weeks. The Odyssey is more than a ship, it's a self-sustaining world, carrying humanity's curiosity to the edge of forever. This is how we become true galactic explorers. The Odyssey's Alcubierre Hawking drive is a triumph of physics. Inspired by Alcubierre's warp bubble and Hawking's black hole radiation, it doesn't move the ship through space, it moves space around the ship. The drive creates a bubble of space-time, expanding it in front and contracting it behind. The ship rides this wave, crossing vast distances without breaking the speed of light. Power comes from a contained micro-black hole, converting matter into energy via Hawking radiation. This energy sustains the warp bubble, allowing safe, rapid travel. Inside, the crew feels no acceleration, just the surreal sight of stars, blue shifting ahead and red shifting behind. Months pass for the crew, while centuries may pass outside. This temporal trade-off is the price of reaching the universe's most distant frontiers. The Alcubierre Hawking drive makes the impossible possible. As the Odyssey nears Cygnus X1, time itself warps. Einstein showed us that gravity slows time, a phenomenon called gravitational time dilation. Near the black hole, this effect becomes extreme. Hours for the crew can mean centuries on Earth. The crew watches the universe outside accelerate. Stars are born and die in days, galaxies swirl in weeks. They become spectators to cosmic history, witnessing the future unfold in fast forward. This temporal isolation is the mission's greatest sacrifice. When they return, their world will be gone, replaced by a future they can barely imagine. They are explorers of both space and time, trading their present for a glimpse of the universe's destiny. It's a lonely journey, but one embraced for the sake of discovery. To reach the edge of the universe, they must leave their own time behind. Hovering at the event horizon is an assault on the senses. Every moment is charged with anticipation and fear, as the crew finds themselves closer to the unknown than any human has ever dared. The boundary between safety and oblivion feels razor thin. The black hole is absolute darkness, surrounded by a blazing accretion disk, matter heated to millions of degrees, brighter than 1,000 suns. The light is so intense it casts shifting shadows across the ship, painting the interior with an otherworldly glow. The crew shields their eyes, awestruck by the raw, violent beauty. Gravity bends light, creating a luminous halo and surreal distortions, gravitational lensing at its most dramatic. Stars appear smeared and twisted as if reality itself is being pulled apart. The view is mesmerizing, almost hypnotic. The crew sees the disc's far side, its light wrapped around the black hole, forming a cosmic ring. This impossible sight defies logic, making the laws of physics feel both familiar and alien. Tidal forces threaten to stretch the Odyssey, countered only by advanced structural fields. The ship groans under the strain, every system pushed to its limit as invisible forces try to tear it apart. A deep vibration hums through the ship, a constant reminder of the immense power nearby. The floor trembles beneath their feet, and the air seems to vibrate with energy, making every breath feel electric. Psychologically, the crew faces awe and terror, staring into infinity, feeling both insignificant and profoundly connected. Their hearts race as they confront the ultimate unknown, emotions swinging between dread and exhilaration. The event horizon is a place beyond human intuition, a boundary between existence and oblivion. It's a threshold that no message or light can cross, a silent frontier that challenges everything they know. Yet, standing at this edge, the crew feels transformed, humbled by the universe's scale and mystery. They sense their own smallness, but also the privilege of witnessing such grandeur. It's a moment of terror, wonder and revelation. The experience will haunt their dreams and shape their lives forever. Here at the brink, they witness the ultimate secret of nature, an encounter that will echo through human history. Amid cosmic extremes, the Odyssey's crew clings to their humanity. They share meals, music, and stories, forging bonds that turn specialists into family. Rituals, birthdays, holidays, anchor them to a past now lost to time. Dr. Eris Thorne, the ship's xenopsychologist, helps the crew process awe and loneliness through art and writing. Their creative works become part of the mission's legacy, capturing the emotional truth of exploration. The crew's laughter, tears, and courage are as vital as any scientific data. At the edge of the void, it's their humanity that shines brightest. Mission complete, the Odyssey leaves Cygnus X1 time, resuming its normal flow. The return journey takes months for the crew, but nearly 4 centuries have passed on Earth. They arrive in the year 2650, strangers in a transformed world. Humanity has spread to new worlds. Technology has leapt forward, and their loved ones are long gone. The crew are celebrated as heroes, but feel like relics, bridges between eras. Yet they do not despair. Their journey has given them a unique perspective on change and continuity. They become teachers and storytellers, sharing not just data, but the awe and humility learned at the edge of the void. Their experience reminds humanity of its origins and the spirit of exploration. The knowledge they bring shapes the future.